Hi everyone, I'm going to show you how Brokk uses code intelligence to make you more productive. So the code intelligence section of the menu is these four items here. And the first of these, summarization, is supported in even the partial level of code intelligence support. So if you look at the Brokk GitHub page, it will list full and partial support for different languages. And so even at the partial level, you do get summarization. And what that means is, as it says on the label, it summarizes files so that if I take the summary of Context Manager here, that's 160 lines of code, and it looks like this. So I'm extracting the declarations and the signatures of Context Manager and the methods and subclasses defined in it, which allows it does two things. First of all, having the public methods allows the AI to figure out how to call into instances of this class correctly without hallucinating. And then having the private methods and instances lets it get a little bit more understanding of what's going on under the hood in this class as well. And that's useful for when we're doing something like deep scan, where I'm giving it instructions and then I want Brokk to tell me what files, what classes, what methods are going to be relevant to implementing your instructions. So having that in the summary, having those private methods, having those fields in the summary is going to allow it to do a better job of figuring out what is relevant to the task that I'm trying to get it to accomplish. So by contrast, if we go and we just edit the context manager file, then it's 1,700 lines of code. And that's pretty typical that you see a factor of about 10x going from full implementations down to the summary. And so that just means you can fit more relevant stuff in your context window because you're using less on stuff that doesn't matter. In the case of APIs that you're just using rather than editing or changing. One other thing that I'll point out with the summarize is first option is to summarize files, and that's what you'll use most often. But you can also summarize a single class, and that's mostly useful if I have a subclass that I'm interested in. For instance, suppose I'm interested in the image file fragment class and not necessarily everything in context fragment. So I can pull in that summary now. And now I'm getting exactly what I asked for. And again, that's more token frugal than doing everything, especially in a class like context fragment where I've got 15 or so of these subclasses defined. And that works not just for what you're doing as a human operator, but when you're using the architect agent, when you're using the search agent, the code intelligence engine is exposed to them as well. And so search, for instance, can ask for, give me the source of method foo and get just that source back. And so you don't run into the problems that you see with some other agentic coding, where if you have the information that it needs buried in a 5,000 line file, it will page through that file 200 lines at a time looking for what it needs. And Brokk doesn't need to do that because it has that code intelligence backing it up. Now the other items here in the code intelligence section of the menu, the usage, the call graph, we do need the full code intelligence implementation to use. So as of the time when I'm making this video, that's only Java, and we're getting other languages onto that list as fast as we can. But right now it's Java. And so let me give you a couple of examples of why this is so useful. And so to do that, I'm going to switch over to the Cassandra project. So I've got a checkout of Apache Cassandra here. And I'm going to take a look at the SS Table Watcher interface. So let's just look at the whole thing to start with. Let's just ask Flash to do it because he's fast. But it said, hey, the build failed. So that's what's going to happen if you just try to code blind in a medium to large project. So let's undo that. And let's add in some more context about how this index API works. So let's just look for index. And that's pulling in a lot of ASCII doc stuff. Let's scroll past that. So we've got index.java. Is that what we want? No, we want the SAI index. So since I've spent that much time talking, let's see. Let's just see out of curiosity if I'm right, and it ends up working. While we're doing that, so that's what we like to see. I'm just going to clear this out, and we'll do that. And we'll just take a quick look at a call graph to commit log segment flush, which when I was working in Cassandra, gave me all kinds of nightmares trying to remember exactly how it's called. And so what you see with the call graph is that it's just giving you the single line of code where each caller invokes its child method rather than giving you the full method source, because when you've got 80 plus call sites or a few hundred call sites, then that's going to chew up your context token budget pretty quickly. And so this is giving you enough to get an overview and know where to dig in more specifically if you need to do that, or if if the agent needs to do that. All right, so let's go back to the Brokk project, and we'll clear this out as well. And the last thing I wanted to show you is dependency integration. And the way that Brokk does that is by decompiling the dependencies in the case of Java. And that's because that's the most reliable way to get the source code for the exact version of the library that you're using. So suppose I want to find how OpenAI, or rather how LangChain4j's OpenAI flavor serializes its requests. And so here's the version that I'm using, LangChain4j OpenAI 1.0 beta 3. So I'm going to go ahead and decompile that. It doesn't take very long. It does say that you need to reopen the project, so we'll go ahead and do that. And now it's going to rebuild our code intelligence to include that new dependency that pulled in. And once that finishes, we'll be able to use that just like our own code, except that it's read-only. And so we'll be able to summarize. So let's go ahead and summarize. What's a class we have? OpenAI chat model. Perfect. So we can go and do what I was showing you earlier about doing recursive summarization. And that's a great way to just pull in, hey, I'm not sure where this information lives in this package, but I'm sure it's in here somewhere, and I want you, the LLM, to figure it out for me. So I'm just going to ask it, where do chat request parameters get serialized in the LangChain4j OpenAI package? And we'll ask it to do that with the, I got a little bit garbled. We're just going to kick that off with the Flash 2.0 model because that's super fast and it's quite good at answering questions like where is the code that does X. And then this is the most relevant suggestion here. It's in a class called JSON. And so we can take a quick look at that. So here's what the JSON class is. It says, hey, we're going to be using Jackson's object mapper, and we're going to wire that up. And then if we needed to know this in more detail, we could ask follow-up questions to the LLM to find out how that object mapper is getting wired up specifically. But that's the basics of using Brokk's code intelligence. We covered the summarization, we covered the symbol usages, and we also covered dependency management. So thanks, and enjoy building with Brokk.